So now we are going to start with basic operation of gas tanker, gas carrier. So this is a ship coming out from the dry dock or yard, and we have to load gas. So first, uh, as we do in oil tankers or some chemical tankers, cargoes also, before putting the cargo or gas to avoid flammable atmosphere, we have to put inert gas. So the process is almost same and but here we have a very pure inert gas generator because gas cargoes are very pure and expensive. So inert gas is generator is there with burner, scrubber and dryer. And gas cargoes are also very water sensitive, and also we are like LNG, we are loading at minus 142 or something. So the dew point, as per the gas, like propane and all, minus 42. So dew point of the gas should be minus, the gas, there should be no water, no moisture. So the gas should be absolutely dry, because if there is moisture, if we cool that is, so there will be some ice crystal, and then it will be a problem with the pump or discharging. So the gas main part precaution of inerting gas should be absolutely dry, and oxygen is less than 1%. So inert gas is going into the tank, and main air is going displaced to the atmosphere. So this is displacement method. So oxygen concentration has to be reduced to below 5%, that we already know. But IG generator gives a very pure oxygen, less than 1%. So dew point of the cargo tank must be lower than the cargo to be carried. So if you're carrying propane, it has to be less than minus 42. Oxygen content, we have different gas meters monitoring for oxygen content of the gas of the tanks, cargo pipings, machinery. Then all the piping has to be also inerted. Pump discharge piping are also to be carried out. Then next is purging. Purging means now we are putting cargo vapor in the gas. So inert gas will come out from the purge pipe. That is called inert gas purging. So that we can go put to atmosphere or to shore as per the requirement of terminal, or if you are at sea or this thing. So this, especially in fully refrigerated or refrigerated cargo of gas ships, when we are putting the cargo vapors, we have to take out the inert gas, because inert gas is not, because of its properties, it's not able to compressed in the reliquefaction plant, which we will see later. So reliquefaction plant is used for keeping the gas cooled. This gas we are loading in the liquid form. Why we are loading in liquid form? Because you can compress it 600 times. If this tank can contain 600 meter cube of gas, then in 1 meter cube only that much liquid can come at that pressure what we are loading. So at that temperature here for refrigerated ships, and for pressurized ship, that pressure. So refrigerated ships, if you are putting the gas at minus 42, this gas will come in 1 meter cube. So that's for that we are using reliquefaction plant, and we need to purge this inert gas out. So this is purging of inert gas or degassing. So cargo vapors we are putting into the bottom, or also on the from the sides we will see. And the gas exchange slowly takes place from the bottom. And also we have to make sure, because when the gas is coming, there will be a lot of pressure rise. We have to continuously monitor the pressure. Of course, it's going out from the purge pipe, but still. And when the content of the cargo gas in the tank exceeds above 95% inert gas, purge or gassing up to be finished. So cargo gas is more than 95%. Then we can finish inerting. Then cool down operation. So as we discussed that this ship, we are loading cargo on a fully refrigerated ship, and whenever you see this shape, also prismatic shape is mostly for refrigerated ships, like you have in your ice cube tray in your freezer. This is called prismatic shape. So from the shore, when we are loading this cargo, it is at minus 42, and our whole temperature is ambient temperature 25, 30, whatever atmosphere you are. If you put the cargo directly, there will be a lot of stresses and it can break the tank. So first we just put the vapor slowly, slowly and cool down the tank to minus 42 slowly, slowly. We are doing it. Generally up minus 10 degrees, 10 degrees per hour maximum. But it will also depend on the design of the tanks and the system. So we have to see the operational manual for that. So cool down is also necessary to avoid excessive tank pressure during bulk loading. So if you are putting lot of cargo at a time and this cargo is actually gas, in normal temperature it will start becoming gas and there will be huge pressure on the gas. So first we are putting the cargo, liquid cargo, very very slowly through these sprayers, top, middle and bottom sprayers. So we start with bottom, then middle, and then from the top we keep spraying and cool down the tank to avoid pressure and bring it to that temperature which we want. These are the spray nozzles of the. So again, monitoring the pressure is very very important, because lot of this, once you're spraying the liquid, again the temperature is normal, so it will be lot of gas will be coming out. So we have to use the reliquefaction plant. Whatever gas is coming out, keep converting into liquid and keep sending in the tank. So let's see the CCR, cargo control room and monitoring system. Almost same with like oil and chemical tanker, with few differences. Cargo console panel, you have all the pumps and all. Then ballast console, all the valves, pumps. Then gas detection system is very important. We in this you have two places, gas detection system in the cargo area, and also in the accommodation part there is a separate gas detection system. Then the cargo control, we have we can control all the operations. We have all the pressure gauges and recorders of the pressure gauges, pressures, levels, with all the with papers. Main and emergency cargo pump, discharge pressure and amperes current, all controls you can see from CCA. Temperature indicators and recorders of each cargo tank. Generally we have very less, like around 5, or this, like we have 5 tanks in oil tanker, same like gas carrier also, it's like that. Then emergency shutdown and alarm for the pumps. Then reliquefaction plant, compressors, parameter. This is different in this gas carrier. Lubricators. Then we have a cargo instrument room. So in the instrument room, we have the starting panel for all the cargo pumps, like you have in engine room. This is separate room. Emergency cargo pumps. If you have a car, like if main pump fails, we can use emergency cargo pump. Then reliquefaction compressor, separate controls, and reliquefaction compressor motor fan room also is separate. So then the control boxes on the deck. There are two boxes, box A and box C, and then you have a pump switch box. So box A consists of all the pressure indicators and pressure switches for cargo tank, hold and reliquefaction line. All the pressure indicators are transmitted to the CCR. Then you have box B, which contains the cargo level indicator and the emergency cargo pump discharge pressure gauges. Then pump switch box contains the main and emergency cargo start and stop switches. Now let's see at the manifold. We have a main pipeline and vapor return pipeline. Then we have pressure gauges for all the pipelines, thermometers for all the pipelines. Thermometer is very important here for the reliquefaction plant, and pressure transmitters and thermometer transmitter all should be, we should have all sensor transmitting to the CCR. Then trunk top. Trunk top is the top part of the tank where reliquefaction line, you have this reliquefaction line temperature indicator. Then all monitoring all the cargo tanks and other cargo related machinery parameters and alarm. We have these console panels which you have in ship's office or CCR, wheelhouse and engine room also. So pressure and temperature level of all tanks we can see everywhere, bridge, CCR and engine room, and all of the associated pipeline also. Then the cargo system and equipment. As per International Gas Code IGC, cargo pipelines are not allowed beneath the deck level. So all cargo pipelines has to be above the deck, and they generally pass through the tank domes and on the main deck. So most of the pipelines you can see are on deck only, no pipeline. And they are fitted with liquid and vapor manifolds. Liquid manifold and vapor manifold. Vapor manifold is generally like this, red, red or yellow. Then you have these pipelines, liquid line, vapor line, condensate line or reliquefaction plant line to make the vapor to liquid again, then liquid and vapor crossover, liquid crossover header, vapor header, reliquefaction line header or condensate header, relief line to relieve the pressure, then high pressure line for booster discharge if you are discharging at a very high pressure, then drain line, then inert gas line for inerting the tank, which we saw in starting. Now let's see the cargo tanks. We have gas carriers have different types of consideration for cargo tanks: fully refrigerated, fully pressurized, or semi-refrigerated or semi-pressurized. So that we will see in detail. So most of the NYK ships, if we see for example, are designated for carrying gas under atmospheric pressure and refrigerated conditions. So let's see the example of LPG, like propane, butane, if it is carried in the refrigerated condition. So we have this example of type A prismatic tank. Prismatic shape I already told you. And type A we will see for pressure less than 0.7 millibars. So because these ships are carrying cargo at very negative temperatures, the tank can have cracks or because of thermal stress. So that's why we have this independent tanks on this gas carriers. So these independent tanks are no way welded or connected directly to the ship hull. Here we have some chokes, which are like wooden supports, wooden blocks, which are kept so that the tank, in case of rolling or something, it should not move freely too much. Then there are secondary barrier or primary barriers. So this is the tank. So the first layer of the tank out outer layer of the main outer layer of the tank is called the primary barrier. Then you have in between the insulation, like you have in your thermos flask or something. So this is full of insulation of perlite. You will see what insulation is this. So this insulation uh, also is asked in orals. So next, after this, whatever the hull surface is there, is the secondary barrier. So if there is a spill, first this will act as a secondary barrier, second barrier, and also we have the first barrier. Then only the spill can take place. Then you have the hold space. This is all empty space. Is called the hold space. It's like you can consider it's a hold of a bulk carrier in which the gas tank has been kept. So this is the hold space, which is empty. So to avoid the leak and all, sometimes we put air or inert gas, depends on different constructions. So this is the tanks. So generally I can see only four tanks. So these gas carriers have big tanks, and you can see a center line bulkhead. So it's a full one tank, which is divided by the center line bulkhead into port and starboard to control the rolling and list and all those things. So these ships are having minimum service temperature of minus 46 degrees centigrade, means can carry cargo up to minus 46 and specific gravity up to 0.61 grams per centimeter cube. Then each cargo tank is fitted with two safety relief valves. These are called MARVS, maximum allowable relief valve setting. MARVS. What is the MARVS setting? It is a special type of pressure relief valves. You can see generally uh, you see this tank is only on the pressure side. You don't have the vacuum side, and there is a spring setting. We'll see this working later on. But this spring will lift up, and this gas will be passing through this. So there will be a pipeline from the tank. If you see, suppose here you have a tank, and from the tank this pipeline is coming and joining here into this relief wall, and then when the pressure is too much above this setting, it will lift the spring and the gas will pass here, and from here the gas will pass through, and there will be venting in the atmosphere, and the gas will go to the atmosphere. Or if we want to send it to a shore, then this gas will go to the manifold, and from manifold it will connect it and go to the shore tank. Okay. So let's continue. So maximum relief fall setting on this ship is minus 2 to 28 kPa gauge, depending on the cargo existing design. All pipelines and equipments to the cargo tank are designed. So this is the refrigerated ships on each vessel. So we have different types of tanks, refrigerated, fully refrigerated and fully pressurized, depending on the gas and temperature. We want to carry it in fully refrigerated or fully pressurized. So this is a typical example of fully refrigerated ship. And you have this prismatic shaped tanks. We have a secondary barrier, which is the outside hull, and we have a primary barrier, which is the inner part of the tank. And then you have insulation with perlite that we will see in detail. Then you have the central line division, for the cargo to avoid moving, and the chokes on which this system is sitting.